Hi guys, Qairul here. Today I'll be sharing with you guys about Euler method. Euler method is a numerical approach for solving ODE to deal with differential equation. It can also be used to approximate solution curve with line segment, roughly obtain the solution yx. Now, let's see how we derive the formula. Okay, suppose we are given the first derivative of dy over dx is equals to an f function. The f function is simply just an expression in terms of x and y. For example, x plus 2y, 3xy, or xy squared. In this graph, suppose we start from the point x0, y0. Keep in mind that dy dx is the first derivative that tells you the slope of the tangent line. When you are given, let's say, start point of x0, y0, you can just plug in into the dy dx here, and then calculate the slope at the point. Let's say the slope goes upwards like this. After adding the line x1 and y1, we will realize that when y1 minus y0, it is equals to m x1 minus x0. From here, you can rewrite to make y1 the subject. Okay, the h stands for step size, and the x0, y0 stands for the slope or the tangent. Okay, now that y1 has become the subject, you will realize that y0 and x0 and y0 still remains the same. But once you move to y2, which is downwards, you will realize that y is actually minus 1, x and y is also minus 1. From here, you can derive the formula of Euler method. Okay, now let's look at a given example. So as we know, when y0 equals to 1, that means that when x is equals to 0, y is equals to 1. Okay, to get xn, we have to use the formula of equals c5 plus d $1. Okay, then we press enter, we will get 0.1. Now, what we can do is, we can fasten the process by bring it down, and you will get the answer. Okay, now that we have found xn 1, we can now start to find yn. Okay, the formula will be d5 plus d$1, which is the step size, times c5 divided by d5 squared, which is basically x over y squared. But you use the values of x and y from the previous n. Okay, once you already type in the formula, you can enter, and you can then drag it down like the previous xn to get the answer. Alright. Now, after we got xn and yn, let us get the actual value of y1. But before that, let me explain this formula. Hopefully you all understand the formula. Now after that, we find the whole of the actual y value, and then as we can see from the graph, that the error difference is barely visible and it's very close. Therefore, Euler method is very useful. Okay, to solve for y1, the actual value, what we do is we differentiate. We bring this up, differentiate. And then once we get the answer, we get the unknown of c. From there, we can find c by subbing in x equals 0, y equals to 1. Once we already find c, we can make y the subject, and then we can work y1 out by letting, when x equals to 1, y equals to unknown. So you find the y. Once you get the y, you sub in the x, you will get the actual answer. Okay guys, that's all from me. Hopefully you guys learned something new today. Goodbye.